Static routing protocol, administrator manually configure routes to reach the remote network. So if you want to forward the packet from 10 network to 40 network, how it works here? So source address is 10 here, destination address is 40, 10.0012 to 10.0.1 to 40.0.0.1 we need to reach. So source address is 10 here, 40 is your destination. Okay, source address is 10, 40 is your destination here. Okay, now you want to forward the packet from 10 to 40 here. How the packet will move here? First, here we can see the PC. We have IP address as 10.01, okay, and gateway as 10.010 here. So the packet will be forwarded to the gateway. Okay, this packet will be forwarded to the gateway here. Gateway is nothing but R1 router. Okay, that is your gateway here, 10.010. It has been forwarded here. Now, what router will do? A router will check the destination address. Okay, it will check the destination address. Whether the destination address is available there in the routing table or not. Okay, whether 40 is available there in the routing table or not. Checking whether 40 is available there in the routing table. Yes, it's available there. Then, where I need to forward the packet? I have to forward the packet to next hop address. That is nothing but 20.0.020. So, what will happen here? The packet will be forwarded from here, this router, to 20.020, this router, second router. Okay, router here, router again check whether the destination address 40 is available there in the routing table or not. Yes, 40 is available here. But what is the next address here? 30.020. So the packet will be moving from, okay, second router to third router here. Okay, in this third router, it check whether 40 is available there in the routing table or not. Yes, 40 is available here. Okay, by directly connected here. 40 is available directly connected. So the packet will be delivered to 40 network here. Okay, from here, the packet will be delivered to 40 network. So this is the way it works, static routing protocol. Similarly, if you want to forward the packet from 10 network to 30 network, what will happen? If you want to forward the packet from 10 network to 30 network here, okay, 10 is the source address, 30 is your destination. So what router will do? Router will check. Okay, first of all, PC will forward the packet to gateway. What is the gateway here? 10.010. So the packet will be forwarded from here to gateway of the router. So it has been forwarded to gateway here. What router will do? Router check the destination address, whether 30 is available there in the table or not. Yes, 30 is available here. What is the next address for 30 here? 20.020. So packet will be moving from here, this router to this router. Here the router will check whether 30 is available there in the table or not. Yes, 30 is available. 30 is nothing but directly connected here. CC. Okay, directly connected. So the packet will be delivered to 30 network. Okay, so it will be delivered to 30 network here. So this is the way, okay, how the packet has been forwarded from source to destination. Now, okay, if you want to forward the packet from 10 network to 50 network, okay, 10 network to 50 network, what will happen here? 10 network to, I want to forward to 50 network. Okay, here, when I want to forward the packet from 10 network to 50 network, it comes to my gateway of your router. Router check whether 50 is available there in the table or not. Okay, checking whether 50 is available there in the table or not. Here, 50 is not available there in the table. Now, what will happen here? If it is not available, the default property of router is nothing but drop the packet. Okay, the packet getting dropped. So, the packet will be dropped here itself. In this router itself, the packet will be getting dropped. Okay, it won't be forwarded to next router, next hop address. Okay, so suppose for example, okay, suppose in my network, okay, 50 network is not available here, but in the ISP side, okay, but second router, if I have 50 network, might be here I am having 50 network. Okay, this network is 50. 50.0.0. This is a 50 network here. Okay, my network 50 is available here. What will happen? Okay, suppose for example, if I forward the packet from here, from source destination, it reaches the router here, checking whether 50 is available there or not. 50 is not available, drop the packet. But suppose if you forward the packet to next router, the router will forward this to 50 network. But here the routes are not available, so automatically packet getting dropped here. Okay, packet getting. So what we can do, okay, is to overcome this scenario here. We have a concept called, okay, default routing protocol. Default routing. What is my default routing? Router route the packet to destination even though the routes are not available there in the routing table. Router route the packet to destination even though the routes are not available there in the routing table. Router route the packet to destination even though the routes are not available there in the routing table. That is called a default routing protocol. Router route the packet to destination even though the routes are not available there in the routing table. So, and also we can say if specific routes for the particular network is not available, normally the router will drop the packet. But when you configure default routing protocol, the packet will be forwarded to the next hop address. The packet will be forwarded to the next hop address. So the default routing protocol is also called as gateway of last resort. That means what? It allow all the traffic. All the traffic has been forwarded to the next hop address. Okay, all the traffic will be forwarded to the next address. First, for example, here, if we configure default routing protocol, what will happen here? So, how it look like default routing protocol? It will be in the form of S star. Okay, that means what? Default routing protocol is also called as static default. So, S star 0.0.0.0 slash 0. What is meaning here? This represents any network. This represents any submask. Any network, any submask, you can forward via next hop address. That's what we are going to configure. Whatever may be the network you are having, any network, any submask, you can forward it to your next hop address. Okay. So if I configure this one, what will happen here? Okay, if I configure this one, what will happen? Okay, like right now, we have source address is 10 here, destination address is 40. What will happen here? Source address 10, destination address 40. So you didn't configure with default static routing protocol here. Now my packet will be forwarded from your PC to the gateway here. Gateway is your first router. What router will check? Whether 40 is available there in the table or not. 40 is not available there in the table. But what is available here? Default routing protocol is available here. Default routing protocol means any network. If it is not matching with the above rule, if it is not matching with the above routes here, it will go for default. Any network, any submask. What I have to do? I have to forward this packet to next hop address. So the packet will be forwarding to your next hop address. Here it check whether 40 is available or not. If it is 40 is available here, it forward the packet. If 40 is not available here, it drop the packet. Okay, that's a default routing protocol. Okay, so where I need to configure default routing protocol? Where I need to configure? So default routing protocol need to be configured in stub router. Okay, default routing protocol need to be configured in stub router. Stub router. Stub router. What is a stub router here? The router which has one exit. Router which has one exit and one entry. One entry. The router which has one exit and one entry is called a stub router. One exit and one entry is called a stub router. So we need to configure the default routing protocol in stub router only. Default routing protocol. So we need to configure the default routing protocol in stub router. Stub router has one exit and one entry. Where I need to configure? So in this router, which is a stub router, we need to identify, right? Very easy here. For R1 router, you can see this is R1 router. R1 router, okay, we can see here, we have only one exit available. So one exit to your ISP. Okay, one exit to your ISP. This the packet has been forwarded to the internet. One ISP to the ISP here. You can see here, one exit here. One entry from the ISP. Okay, what about this one, sir? This is nothing but your LAN. Okay, this is nothing but your LAN. So we are talking about one exit and one entry to the ISP. So we can configure default routing protocol here because this router has one exit and one entry here. Similarly, for this router, lost router, auth router, here also you can say here we have one exit and one entry here. How we can say one exit here and one entry here. Okay, to the right. This is LAN connection. This is LAN. Okay, one exit and one entry to the ISP. We are talking about one exit and one entry to the ISP. So we can configure the default routing protocol here in the auth router because this is a stub router. Stub router. So we can configure stub router. We can configure the default routing protocol in stub router, which has one exit and one entry. That is nothing but R1 router. Similarly, R2 router also, we can say one exit and one entry. Okay, so this is called a stub router here. But R2 router has two exit. How we can say two exit here? Okay, we can say this end actually, we can exit here, two exit here. This end also I can forward, this end also I can forward. Two exit here. Two entry. This end also it enters to the router. This way also it enters to the router. That means what? Two exit and two entry to the ISP. Okay. So R1 router has one exit and one entry. R2 router has one exit and one entry. R2 router has two exit and two entry. So where I need to configure in default routing protocol? I can configure default routing protocol only in this stub router. Here in this case, this is your stub router. R1 router and R2 router is your stub router. I can configure an R1 router and R2 router. I should not configure in R2 router, or because R2 has two exit and two entry, we should not configure. Sir, then what we need to configure there in R2 router? In R2 router, we have to configure static routing protocol. Okay, so here we have to configure default routing protocol. Here also we have to configure default routing protocol. Here we have to configure static routing protocol. Okay, so understood? So default routing protocol. Default routing protocol is nothing but the router check whether the routes are available there in the routing table or not. If the routes are available there in the routing table, it forward the packet. If the routes are not available there in the routing table, it drop the packet. But when you go for default routing protocol, even though the routes are not available there in the routing table, it forward the packet to your next hop address. Okay, so where I need to configure default routing protocol, I have to configure the default routing protocol in stub router. What is stub router? The router which has one exit and one entry to the ISP. Okay, so here R1 router, how many exit and how many exit entries are available? You can see here one exit and one entry. In R2 router, one exit and one entry. In R2 router, two exit, two entry to the ISP. Okay, so R1 router, one exit, one entry. R2 router, two exit, one entry. R3 router, one exit, one entry. So which is a stub router here? So R1 router is a stub router. R3 router is a stub router. So we can configure default routing protocol in R1 router as well as R3 router. So what about R2 router? R2 router we have to configure with static routing protocol. Static routing protocol we can configure. Suppose for example, so you can assume here, sir, here also we have router available. Okay, might be you can say here R4 router, here R5 router. Okay, R4 router, R5 router. Another two routers are available here. So what will happen here? So in this scenario here, might be I can take an example. Okay, another example here. Okay, in this setup, here we can say I am having R4 router and R5 router, sir. Okay, here I am having R4 router, here I am having R5 router. In this case, where I need to configure default routing protocol. So always you can remember here the router edge router. I can say here stub router, which is have one exit, okay, one entry. This router we have one exit and one entry. What about R4 router, R3 router also? We can see here two exit here, two exit, two entry. Here also two exit and two entry. So in this case, here in this middle three router, we can go with what? We can configure the default router, static routing protocol. Here in this router only, we can configure default R1 router as well as R2 router. We can configure default routing protocol. R2 router, R4 router, and R5 router. We have to configure the static routing protocol. Okay, simple. How to configure default routing protocol? What is the syntax? What is syntax for configuring default routing protocol? What is syntax for configuring default routing protocol? So what is the command? IP route. In the router, you need to configure router config. Okay, syntax is nothing but IP route. Okay, we can say destination network here is nothing but any network, right? So I mentioned any network 0.0.0. So 0.0.0. Okay, any network, any submask. Then we can say next hop address. Next hop address. This is called as what? Okay, default routing protocol. IP route. Okay, router config IP route 0.0.0.0.0.0 next address. It's nothing but default routing protocol. So R1 router, how to configure default here, default routing protocol. So I have to configure default rate R1 router, IP route. This is command IP route. So 0.0.0.0.0.0.0.0. Next hop. What is the next hop for R1 router? We discussed, right? Next hop is nothing but next jump. For R1 router, who is my next hop here? Next jump. So okay, next jump is nothing but next jump. We can say here next jump here. What is the IP address available? 20.0.20 is your next hop address. So you can say 20.0.0.20. Similarly, R2 router. R3 router. R3 router also we need to configure the default routing protocol, right? Default routing protocol here for R3 router. What is the default here? I need to forward the packet to next address 30.0.0.10 here. So I can say in R3, I can configure in R3. On 3, I can configure IP route. IP route 0, same thing 0.0.0, 0.0.0.0, next hop address. What is the next hop here? 30.0.0.10 here. That is the next hop address. Okay, then what about R2 router? R2 router config. R2 router config here. IP route. IP route. Destination network. For R2 router, who is the destination here? 30, right? 30.0.0.20 here. Okay, so 30, not 30. R2 router. Okay, there are two networks, 10 network and 40 network. You need to write the route, right? So I can say 10. First, we will write the route for 10 here. 10.0.0.0, 0. Okay, 255.0.0.0. Your next address is 20.0.0.10. Okay, yesterday we discussed, right? Similarly, for other network, R2 router config here. IP route. IP route 40.0.0.0. Okay, 255.0.0.0. Okay, next address is nothing but 30.0.0.20 here. It's a 30.0.0.20. Okay, this is your next address here. Okay. So this is these things we need to configure in the R1 router, R2 router, and R3 router. Okay, this is called as what? Default routing protocol. Here we are configuring static routing protocol. Here in R3 router we are configuring default routing protocol. After that, when you try to ping the packet from here, it automatically reaches the destination. So we will configure the static routing protocol first of all. After that, we remove the static routing protocol. Then we will configure the default routing protocol. Okay, we will go the scenario here. So I will take 3 router here. Okay, R1 router, R2 router, and R2 router. Okay, first we need to configure the IP address everything, right? Take a switch here. So 2950 model switch here. Okay, again switch another end. Connecting with the PC. Two PC here. First PC and last PC here. Open a router. Power of the machine. Add NM4 race card and power on the machine. Okay, open the router. Power off. Add NM4AS and power on. Open the router. Power off. Add NM4AS and power on. So connect all the cable here. Okay, starting from first here. First cable here. Another cable from here to here. Okay, all the cables are connected. Okay, so I can assign the IP address here. Before that, I can note down the IP address in the router interface. Okay, 10.0.10 here. So here this interface with configure with, I want to configure with the 20.0.10. Here I want to configure with the 20.0.20. So configure with 30.0.10, 30.0.0.20 here. .0.10. So first thing here 10.0.0.1. 255.0.0.0, 10.0.0.10 here. Okay, here 40.0.0.1, 40.0.10. Now I want to configure the IP address for the router here. Step by step command. Open the router, go to the CLI mode here. First thing, no command. Enable, okay, config T. So host name, you can assign the host name. Okay, host name, okay, R1 router. So interface F8070, IP address. So 10.0.0.10, okay, 255.0.0.0, no shutdown command. Okay, exit. Interface serial 170, IP address 40 dot, okay, 20.0.0.10 here, 255.0.0.0, no shutdown command, clock rate 64,000. Okay, finished. First router configuration over. Go to the second router. Okay, configure the same here in second router. Okay, CLI mode, no command. Enable, okay, config T, host name as R2. Okay, interface serial 170, IP address 20.20.0.020, 255.0.0.0. No shutdown command, no shutdown. Okay, clock rate, exit. Interface serial 1/1, IP address. Okay, 30.30.0.010, 255.0.0.0. No shutdown. Clock rate 64,000. We can apply. Finish. Second router configure with IP address. We can go with third router. Third router, no command. Enable config T, config T, interface serial 1/0, IP address. Okay, IP address 30.0.0.20, 255.0.0.0, no shutdown command, clock rate 64,000. Exit here. Interface F8070, IP address. Okay, 40.0.0.10 here, 255.0.0.0, no shutdown command, exit. Finished. So this is nothing but host name of R3, right? Configure. All the routers has been configured. R1, R2, R3. Okay. Now I want to check my routing table. What is the next step actually? After configuring the IP, we have to check the routing table whether it's available there in the routing routes are available there in the routing table or not. Show IP route command. R1 router has 1020. Okay, correct. Currently configure. So check the second router. Show IP route command. Show IP route command. R2 router has 2030. Now show IP route command in R3 router 3040. Okay, 3040. Now R1 router I want to configure the static routing protocol. First I will show you the static routing protocol. Then we will change it to default. Okay. So IP route command, IP route, destination network is nothing but okay 30.0.0.0, 255.0.0.0, next address nothing but 20.0.0.20 is the next address. Similarly 40 also I can configure 40.0.0.0, 250.0.0.0, 20.0.20. Finished. R1 router, R2 router. Configure R2 router here, IP route 10 network you need to configure 10.0.0.0, 255.0.0.0, next address nothing but 20.0.0.10 here. Okay, this set, right? Similarly, IP route command, okay, 40.0.0.0, 255.0.0.0 here, next address nothing but 30.0.0.20 here. Okay, third router, IP route command, okay, we have to configure with 10 and 20, 10.0.0.0, 255.0.0.0 here, okay, 30.0.0.10 is your next address. Similarly for 20 also 10 is your next address. Configure, all the routes are configured. Now we can check the routing table for all the routers here. So it has to, okay, all the routes has to be available here. You can see here 10, 20, 30, 40. All the routes are available here. Second router also you can check it. Show IP route command. All the routes are available here 10, 20, 30, 40. Third route, okay, you can see here also. Show IP route command. All routes are available. Okay, all routes are available. Now I want to configure the IP address for the PC. Okay, I want to configure the IP address for the PC here. Go to your desktop. IP config command. Here 10.0.0.1, 10.0.0.10. Okay, 10.0.1, 10.0.10. Okay, finish here. Last router, last PC. 40.0.0.1 here, 40.0.0.10. Okay, so now forward the packet here from here to there to here, ping command, ping 40.0.0.1 here. Okay, so packet is reaching, right? So packet is flowing, but how it flows, I want to check it. Okay, I want to give the trace command, trace rt 40.0.0.1 here. So you can see the trace here. Okay, it goes for your 10 from 10 from your PC to 10.0.10. Okay, 20.0.20, 30.0.20 and 40.0.1. Okay, so packet has been moving from here to here, then 20.0.20, 30.0.20, 40.0.1. This is the way packet has been moving. Okay, suppose if I give 50 here, what will happen? Okay, it won't reach, right? 50 is not available there, so it won't reach the 15 network because 50 is not available there in the routing table. It says the destination host unreachable, but I want to check where the packet is getting dropped. Okay, so I want to check where the packet is getting dropped here. So if I give, okay, trace command of 50.0.0.10, what will happen? It's checking. Okay, 50 is from here, it is forward to gateway. It's checking here 50 is available there in the table or not. 50 is not available there in the table, so it dropped the packet here itself. It won't forward to 20.0.20. Okay, dropped here itself. You can see here, if I apply this command, so you can see after that it won't forward there. The packet will drop here. So continuously you are getting 10.0.10, again 10.0.10, because the routes are not available there in the router. Continuously you will get 10.0.10. There is no routes available there in the router. Again you will get 10.0.10. The packet will not get forwarded. Okay, clear? So packet is now getting forwarded to the next address because the routes are not available there in the routing table. Okay, so I can give Control C here, skip it. Now I want to remove the static routing protocol in R1 router. How to remove the static routing protocol? Same, you have to go to configuration mode. We have commands available, 2 commands available, right? In front of it, we can apply no command, no IP route, complete command 30.0.0, 250.0, 20.0. Remove my static here, 30 network removed. Similarly, I want to remove my 40 network also. Remove. No command in front of it, remove. Similarly, okay, second router, okay, second auto router also, okay, I can remove it. Okay, remove the command here, no command in front of it. Okay, similarly, I can remove all the routes I want to remove, no command in front of it. Okay, remove here. Third router also I want to remove. Okay, configuration mode here, I will remove this one. No command, remove here, no command, I'll remove. Now the router has been, all the three router has been configured with their IP address only, right? So you can see whether what is the route available there. You can see 1020 available. No routes available here, only 1020 directly connected network available here. Here also you can see 1020, 2030 available, 3040 is available here. Okay, 3040 is available here in the R3 router. Okay, now I want to configure with default routing protocol. This is my default routing protocol, right? For R1, I need to configure. I have to configure with this command, R1 command 0.0.0.0.0 next address. R3 I have to configure with this command. R2 I have to configure with static routing protocol. So I can apply here. Go to R1 router. R1 router I want to configure default routing protocol. What is the command? IP route. IP route 0.0.0.0 next address 20.0.0.20 is the next address. Finish. That's all. Command is over. Auth router. Auth router I can configure. Go to configuration mode here. IP route command. IP route 0.0.0.0 30.0.0.10 here. Okay, finished. Now comes to auto router. Here we have to configure with what? Static routing protocol, right? Okay, click static routing protocol. First is static routing protocol. Static route configure here. Now I want to check my routing table in all the three router. When you check here, it will show, okay, S star here. S star represents what? Default. Okay, static default we can say. Static. S represents static. Static default we can say. S star static default. Okay, this is nothing but what? Any network, any submask. Go over here, next hop address. So 10.0.0.0/8. Okay, that means 10 network and 10 network. It can be applied 10 network and 20 network has been reaching via, okay, see, connected network. Connected here, directly connected. One second. So 10.0.0.0 slash 8 here, 20.0.0.0 slash 8 here is connected with directly connected here. S star 0.0.0 slash 8. That means what? Any network. Okay, any network. That's called a default routing protocol. Okay, forward area next address. Now we will check the packet here, how it flows here in the router. Okay, so first of all, I want to ping from here. Okay, ping 40.01. First PC to last PC here, 40.01 here. So simulate trace command is also it's working fine. Okay, so default routing protocol is properly working. But what I want to do here, I want to try with the 50.0.0.1. What will happen if I forward 50.0.0.1 here? If right now I forward with the default routing protocol, right? So default routing protocol, if I try with the default routing protocol, okay, like from reaching from 10 network to 10 network to 40 network here, the packet has been forwarded to your router, first router. You check whether 40 is available there in the routing table or not. Yes, okay, 40 is not available, but we have default routing protocol available. Default says that you need to forward it via 20.0.20. The packet will be forwarded here. Here, if we have 40 networks available, so forwarded here, okay, to next address here. Here it's checking whether 40 is available or not. It's directly connected, so it reaches the 40 network here. But right now, I want to forward the packet from 10 network to 50 network. What will happen? 10 to 50. 50 network, 10 network to 50 network. What will happen here? Okay, the packet is forwarding from here to this router. Router check whether 50 is available there in the routing table or not. It's not available. But what you configure here? We configure with the default routing protocol. Okay, 20.0.20. So what will happen here? Okay, so packet will be forwarding from here to next router. When checking next router 50 is not available. Okay, it's not 50 is not available there. What will happen? The packet will be getting dropped here. Okay, so when you try to ping from here, okay, it says, okay, request timeout. The packet cannot be reached. But when you try to give traceroute command, what will happen? The packet will come here. It's checking whether 50 is available or not. But default routing has been configured. Okay, 50 is not available. Default is configured. What will happen? The packet will be moved to here. It's checking whether 50 is available here or not. 50 is not available. The packet will be getting dropped here. Which network? 20.0.0. Okay, 20. The packet will be getting dropped here. Not here in this. Okay, previous case 10.0.10. The previous scenario, the packet is getting dropped in 10.0.10, right? 10.0. Now the packet will be getting dropped in 20.0.10. Okay, we'll see that also. So first we will apply ping command. Ping 50.0.0.1 here. You can say destination host unreachable. You cannot be able to reach the 50 network. But I want to give traceroute command. Trace of 50.0.1 here. If I apply trace command, you can see here the packet goes up to 20.0.20. There only its packet is getting dropped. By this we understood that okay, default routing protocol will forward the packet even though the routes are not available at the routing table. Clear? Thank you.